Bristol Community College, Mathematics with Dan Avedikian, Math 011, Arithmetic, Section 2.7, Problem 10. This is Section 2.7, Problem 10. It says find the least common multiple for the numbers 30, 48, and 60. So again, what are we looking for really when I say least common multiple? I want the smallest number that 30 divides into evenly, 48 also divides into evenly, and 60 also divides into evenly. And what makes number 10 here a little different than most of the other problems in this homework section is there's 3 numbers to find the least common multiple for. If there's 2 and they're not too big, you do have some type of shot at guessing at it. But once you make it 3 or more, the process is the same, but you're not likely to be able to guess at it. You have to do the prime factorization and go through the steps. So let's go ahead and do that. Start with the 30. What's the prime factorization for 30? So 30 I can split into 6 times 5. And again, it starts a bunch of other ways, 3 times 10, 2 times 15. This is what really jumped into my head. So you get to the same spot either way. So the 6 will break into 2 times 3. The 5 doesn't split. Just bring it straight down. So 2 times 3 times 5, those are the primes that multiply to make a 30. So 2 times 3 times 5. I'll write that right underneath the 30. And now 48. Do the prime factorization for that. And again, there's many, many ways to multiply and make a 48. The first thing that pops into my mind is 6 times 8. And again, if you see something different, just go with that. In the end, you'll wind up with the same primes. The 6 can split again into 2 times 3. The 8 can split into 2 times 4. Now, the 4 at the end can split again into 2 times 2. So the first 2 I'll bring straight down without splitting. The 3 next to it I'll bring straight down without splitting. So 2 next to that I'll bring straight down without splitting. And then the 4 at the very end I'll split into 2 times 2. So I have 1, 2, 3, 4 2s and a 3. So that'll be, for the 48, I'll have 2 to the 4th times 3. And then finally the 60, I don't really have room to keep going any lower. So I'll just write out the 60 up on top here. You can start it many ways. The first thing, again, that comes into my mind is 6 times 10. It's a good starting point. They can both be broken down again. The 6 can split into 2 times 3. The 10 can split into 2 times 5. And at that point, all the numbers are prime. I can stop. So 2 shows up twice, so I'll write that as 2 to the 2nd power. 3 shows up once, so I just do 3. 5 shows up, so I just do times 5. So now I have the prime factorization for each one of the numbers in my list of numbers that I have to find the least common multiple for. The next thing I do is just make a list of any prime that shows up in any of those prime factorizations. So I'm using 2, 3, and 5. Those are the primes that get used, 2, 3, 5. Next, what I want to do is consider the exponents for these primes and take the largest exponent for each one. So for the 2's, I have 1st power, 4th power, 2nd power. And I want the largest exponent. Well, 4th power is the largest exponent. It's bigger than 1st power. It's bigger than 2nd power. So for the 2, I go for 2 to the 4th power. Now the 3 shows up in all of them, but it's only 3 to the 1st power, so it'll stay just 1st power. The 5 shows up in a couple of spots. Again, both times only to the 1st power, so it'll stay 5 to the 1st power. So what I have to multiply is 2 to the 4th times 3 times 5. The 2 to the 4th, there's 4 2's multiplied together times 3 times 5. So let's see, 2 times 2 is 4, another 2 times 2 is 4 again, 4 times 4, so I'm going to have 16, 3 times 5 is 15. So if I multiply 16 times 15, that'll multiply out my answer. So 16 times 15. So 5 times 6 is 30. Write the 0, carry the 3. 5 times 1 is 5. 5 plus 3 more that I carried is 8. So now I'm done with the 5, deal with the 1. Go down 1 line, put in a 0 to hold your spot. 1 times 6 is 6. 1 times 1 is 1. Add those results together. 0 plus 0 is 0. 8 plus 6 is 14. Write the 4, carry the 1. And then the 1 I carried plus the 1 underneath is 2. So I get an end result of 240. And again, what that means is 240 is the smallest value that 30 will divide into evenly. 48 also divides into 240 evenly. And 60 also divides into 240 evenly. And that's the smallest value that they all divide into evenly. So they divided these other numbers, like they would go into, say, 2400 evenly, but 240 is the smallest one that they all divide into evenly. And again, why is that an important thing to find? The answer is, if you had a problem with fractions and you had denominators of 30, 48, and 60, the lowest common denominator for those denominators would be 240.